Who will explain it?
Yes, I will explain. Thank you.
Okay, please.
So good afternoon, everyone. So this talk continues from Meurig's talk earlier, if you were here for that. And I hope to give a more practical angle on how this environment called JS Eden could be used in the classroom. So this is some work that we've been doing as part of the Constructionism project, and this particular work that I'm presenting had a number of people make significant contributions, including Rene from Edumotive in Greece, and Peter from Cornelius University in Bratislava, as well as Meurig and Nick, who has been the main developer on this application. So it's just something about the project, you can go and find out more on the website. So I'm going to start by saying something that is not related to my paper. Currently I work in primary school, and one of the topics that we're looking at is teaching programming. And one of the things I notice when working in primary schools is how challenging it is to teach anything other than programming. So when we're trying to get the students to program, they are trying to learn programming. They're not using their programming skills to explore mathematics or other topics like in the arts or anything like that. And I don't think that's really in the spirit of Appet's idea for constructionism. He said many times that programming was a way to open up a new world of learning in many different domains. Okay, so this is going to be a topic of my talk. So this is the challenge I think that many of us are faced with, is instead of just learning programming for the sake of programming, how can we get students to learn programming to open up a wide variety of learning experiences. And there's two perspectives which I talk about in the paper, which I'm just going to quickly highlight here. And one is this view that we're stuck in a technocentric view, meaning that we focus too much on the technology, on the programming, and not enough on the domain of learning. And the second one from Ackerman is saying that the digital natives concept of programming is much broader than perhaps a computer scientist view. And so what I'm going to say here is quite bold, and I'm not going to speak too much about it because Meurig has already said something about the differences between making construals and procedural view of programming. I'll just say these 2 points, that I think that the procedural view of programming is quite limited in terms of supporting this wide range of learning activities. And we think we have a better alternative way of constructing things, which is this idea of making construals. And I think this is conceptually more accessible to young people. Usually when we think of making things more accessible, it's usually simplifying them and making things more limited, reducing the complexity, giving highly graphical environments, but the students are not able to do as many things. But I don't think we're doing that. I think we're making it more accessible, but still leaving open a wide range of activities in a similar way as a Scratch environment or another programming environment might do. So, making construals. Construal is something that is built up incrementally. It's a live artifact. So it's not a program that you compile and run. It's something that's always live, and we're slowly adding things to it, adding definitions to it. The states, the things that we represent in our construal, I like to think that they have some meaningful association with something in the real world. Having the model in the computer should be somehow related to some referent in the real world. So this is the JS Eden tool. This is actually an earlier version that we used in the high school in September last year. And there's three components to the screen here. On the left-hand side, you have a list of all the observables. Observables are a little bit like variables. They're something that has some state. And we can see a list of all of those that are in the model, and the student could change any of these at any time. The input window on the bottom right-hand side is the place where we can edit the observables or add new observables to this model. And the top right is this canvas or picture, is when we're drawing lines and objects, they're going to show up in this picture. So the workshop that I'm going to talk about in this paper is, it was a short workshop that we did in Athens. The workshop actually involved many activities, but the one I'm talking about was one afternoon we spent in a high school. And we spent 3 teaching periods with about 25 students who had never used this environment before. And we didn't teach them anything. I spoke for about 2 to 3 minutes at the beginning of the class. Didn't give them much introduction. We mainly focused on a worksheet that we wanted them to work through. However, there were lots of our team on hand to help, so the students did have a high number of facilitators to help them as they went along. So the worksheet, I'm going to show you 3 slides to give you a feel for what the worksheet was like and the type of activities that the students were doing. So dependency is one of the principles behind building construals. We were specifically talking about triangles, and the next task was about drawing lines and how to build up 3 lines to make a triangle. And there was questions related to Pythagoras' theorem to be able to calculate the length of a right. Complicated, and we introduced animation and various other concepts to them. In the last 3 tasks, there were a total of 11 tasks. The last 3 tasks were focused on building a model of the solar system, which involved some mathematics, involved some animation, it involved knowing a bit about how many times different planets rotated around the sun, and we gave them a certain amount of information. Okay, so I'm going to give you a quick demo of some of these things to give you an idea of what it looks like. Okay, so this is the environment, and I'm just going to show you from maybe task 2 or 3 how we would go about creating dependencies in this environment. So endpoint, which might be 150. When I create a line, it doesn't yet show up on the canvas until we specify that. So I'm going to say the picture is defined as a line. And now we can see the line on the screen. Now in order to show dependency, I'm going to introduce another observable called A. I'm going to set this to be initially 75. And then I'm going to go back to my line definition, and I'm going to say, instead of the x distance being 100, it's now going to be A. So now I've created dependency between the line that's shown on the screen and this observable A, which at the moment is 75. And so the line has now moved, and now if I change the value of A, then also the line updates. So this is a very, very simple example, but I hope you can imagine that as we build up many dependencies of anything, pretty much, and in some of Meurig's work, we've looked at lots of different subjects, not just mathematics. Okay, so I want to quickly show you the solar system, which I've prepared a little bit of this in the background. So when we defined the solar system, I started off by defining a sun as a circle and giving it the color gold and giving it some position on the screen defined by an origin x and y. And the first thing I will do is just show the picture as the sun. Okay, so this was the first part of building the solar system, and the second part was building a planet that moves around the sun. And so here, this was some of the more difficult mathematics that the students had to struggle with. So there were 4 definitions here to set up the movement of an Earth around the sun. And if I just also add that to the screen. We'll see that now there's an Earth rotating. So with a relatively small number of definitions, we can even do things like animation. I'll add one more thing to the screen, I think. I'll add the whole script to the screen so you can see. You can see the final product of what the students were trying to create within those 2.5 hours was something like this of a model of the solar system. And they had to think about how many times the planets were moving around the sun, and this was quite challenging, and not many of the students got to this final stage. Okay, I'm going to go back to the presentation now, so I've got a little bit of time to explain what we did next. So the results come from the observations of the team members that were there, and also an interview that we did with the teacher. We recorded all of the student interactions in the environment, and I'm going to show you some of those in just a moment. So here's some of the students. Some of them worked in pairs, some worked in threes. So I'm going to pick out tasks 2 to 4, which, as I mentioned, were related to drawing triangles and Pythagoras theorem. And this was a very early stage of the worksheet, within around half an hour into the session. And remember, they'd never seen this environment before. And 2 of the challenges with these tasks was some of them had not yet we asked them to use Pythagoras theorem in one of these questions and apply it in order to draw some triangles on the screen. And this was very challenging too. So here's some examples of what the students did. This is just one group that we picked. Here you can see the time that these things were occurring. So in the comments, the lines preceded by hash are saying what time this occurred. So you can see here the students are doing something to do with square root, probably to try and understand how square root works. And then on the third line, they try to make a definition of C, which is one of the questions in the tasks that I showed earlier. And you might notice that the definition for C is wrong, that the square root, when we calculate C, it should be the square root of a squared plus b squared. So the a squared and b squared should be all within the brackets of the square root. And so this is an example environment here. Their mathematical knowledge is a problem. But they're able to fix that. Either they fix it on themselves, or one of the helpers has directed them. The second group I want to... Okay, thank you. The second group I want to show something that is a different type of mistake or struggle that we noticed. And this group, they were doing okay. If you look down at the line on 30 minutes, they have a correct mathematical understanding. So they understand that c squared equals a squared plus b squared. But this is not accepted by the environment, and this is actually an error, because they have a misunderstanding about how to use assignment, the equals operator. And also this group, eventually they were able to get the correct definition. Although they still haven't used the dependency correctly, so they still had some problems. Okay, the third group is another type of problem that we found when we analysed these scripts. And this was this was a group that I think was one of the better groups. They managed to get the correct definition for C right at the beginning, or quite early on, within 15 minutes of starting the worksheet. And but as they moved on and started to draw the line, they had a lot of problems applying the definition that they created for C in order to draw the line. So you can see between 29 minutes to 43 minutes, they tried many things, and actually I've deleted a lot of other things that they tried, where they were trying to apply Pythagoras' theorem within the line and not really understanding what they were doing. So this is another thing where they had trouble applying the knowledge. So I'm going to say, I think we noticed three things in these examples. Was that some had problems purely with the maths, some had problems, no problem with the maths, but had problem describing it in the environment, and others had problems about how to apply the maths to do some construction in the environment. So a few other observations and feedback that we received from the observers. Many people said the second thing was really interesting. And one of the observers said that the students were not able to access their basic mathematical knowledge, and this is despite the teacher saying that the concepts, the mathematical concepts that we use should have been familiar to them. But one of the observers was saying that they were not able to apply Pythagoras' theorem in this workshop. And the suggestion here is that perhaps the students were expecting to program and they were not expecting to do maths. I think there was one comment relating to I think that should be quite worrying to us that we're narrowing our students down to think of programming in this way. Anyway, some comments from the students. After we left Greece, a week later, the teacher had another session with the students, asking them to reflect on the session, and we got a lot of good comments from this. Some of the students had previously done Scratch, and some of the comments that came back were saying that they felt they were doing some serious programming in here, like it was more difficult than what they'd done before, which was interesting. Many of them commented on the difficulty and the problems that they had on the worksheet, and I want to highlight one student in particular who said was really quite negative at the beginning of their diary, saying, didn't go well, it was really difficult, they couldn't find a solution, and they didn't complete it on time. And then later on in their diary, they're really quite positive and say they enjoyed drawing the pictures, the figures in the pictures, and it was fun and enjoyable. And one of the other researchers in the team said, this is an example of math that's hard fun. Like you can mix hard and fun together. It's all good. Okay, so that's just about it. I want to go back to what I was saying at the beginning and say that we think this is possibly a more accessible environment for doing programming. I will say just that and take some questions, perhaps.
So thank you, Antony.
Project. It's an EU project that Meurig is leading at University of Warwick, and there's a number of partners, and it comes from this idea of making construals. And making construals is our...
That's a different word for construit.
Sorry?
Another way to describe this word, construit.
Maybe Meurig will answer this.
Sense-making artifacts.
Is it interpretation, for example, description, understanding?
A construal generally is how you understand something, how you make sense of something. But in our case, it's also how you build things on the computer that you interact with to explain how you understand it, to make it communicable in some way.
yeah, I think it's quite a constructionist idea, really, that we're thinking about or how we interpret something, but the way we're using it is building things in the computer. It's construction.
So it's often used.
Construals or like this whole concept of construal. But why is it not something? Why is it dependency? Or am I not? Huh?
I think that the fundamental thing is that dependency helps us to make the connection between what we see on the computer and what it's meant to mean in the world. So spreadsheets are a very good example. If you have a spreadsheet, if you imagine a spreadsheet where you had exam marks with student names and there were no calculations being done for you, then you wouldn't be able to connect the cells with the... It's because they have these particular connections that you can say that is an exam mark and this is the average for the course. So dependency is a way of making connections in your mind.
I had this idea for a long time. Maybe not too related to this, but there was a funny video that they kind of like remove off. So Thailand, in Thai language, you have like 46 alphabets or something. But there was like, you just use like only one alphabet, but by the context of, like of course, different vowels. But then you make like a whole sentence, and then once you listen to it enough, you begin to understand what it really means. Even though it's like, 1 divided by 40 times complexity, is that like kind of related? Because of the relationship of the, neighbor of this.
Yes, definitely. A lot of the understanding that you build up in interacting is a result of doing things often enough. So not only does it vary from person to person how they interpret things, but the same person will have a different understanding after they become familiar. Just as in language, initially you find it difficult to understand a sentence, but if you hear it often enough, it becomes something you take for granted. So that's a common feature of our work as well.
Is this a relation between the planets and the formulas?
Yes, that's a very simple example.
Yes. And was it the goal of the project to formulate it like these formulas? Is it to learn how to do it in a formal way to describe describe something in a formal way? Was it the goal?
It's an alternative to procedural programming. So quite a lot of procedural code in order to do something like that. Whereas if you use dependencies, you can get away with a small number of connections to generate something which looks quite complicated. But if you think about the dependencies, there are not so many dependencies.
So you describe the Newton formulas of
yes,
planets and
the reason why we're doing this and why we think it's important for education is because it simplifies the construction in some way.
We choose a simple construal in that case because we want to highlight the techniques that the students have to learn.
okay. You have another question?
Do you have time?
Hopefully, yes.
I was really interested, and this slightly pulls on my presentation earlier. It's all the questions I wanted to ask you. You were, at the very beginning of your talk, you spoke about some Pappas early writings. And one of the things that you were saying about the importance of programming the computer and understanding that you're programming a computer. But Pappas, talking about the value of computers and the power of computers, was saying that but that you're actually able to get to those deeper concepts more easily through the computer, and that's what that's where the power is. In my opinion, that's where the power is. What I'm wondering when I see the example you gave, or the snapshots you gave earlier, is that this looks like a complex environment, and it doesn't seem like an invisible place where I can get to those concepts. And I wonder what you think about that comment, and I also wonder whether or not that has a link to what your students were saying when they were saying, we thought we came to do programming, we ended up doing maths. Maybe they're not related, but that.
I think it's a compliment to the student that do maths. because it means that.
Sorry, I think it's a compliment that the students thought that they were expected to come and do programming, but they felt they were doing maths. It means that they weren't thinking so much about programming the computer. The thing that was challenging to them is accessing their mathematical knowledge. So that's one perspective. I'm not sure whether that was what everyone felt in the group. I'm sure some of them struggled with the tools as well and share the same view that you do, that when you look at it initially, there's a lot to take on board in learning the concepts and the layout of this tool. But probably they would have that same reaction the first time they look at Scratch or any of these environments. But yeah, I agree with your comment that we do want to get towards that where we're not thinking about the programming, not thinking about that, and more engaging with some domain learning. Maybe Meurig has some more to add.
One thing, because I know we're running out of time. But for me, recently, being the best hook into what we're doing, it looks like a complicated environment. But actually, what we're encouraging you to do is to look at two parts of the screen, or possibly to look at a part of the screen and think about something in the world and make a connection. So it's not so much, you shouldn't be grubbing around the detail. You should be thinking of an experience. And that, I think, we're getting more successful.
So you say a certain level of opaqueness is make it useful in the learning process?
Definitely we shouldn't be looking at these things in detail in some ways.
But not completely invisible.
Well, by no means completely invisible. It's more a question of you select what you should be looking at. In one of the presentations, I gave 3 online links this morning. I briefly talked about all 3 things. One of them is stressing the making connection. So I tried to highlight what the expert would be looking at and thinking about in that very complex screen.
So it's more like shining a light on something.
Yes, so if you attend to how this relates to that, you get that right, and then you take that step further, how this relates to that. And you're quite right, the question of what's invisible, it varies to the level of expertise. But there's a reason that the environment is the way it is. It's mostly to do with its making connection.
Okay, making connection, it's more modeling than a programming. Isn't it?
Very much true.
Because it's more modeling, so it's also more mathematics. Because you have to describe the relations.
Yes.
Okay. Yes, Karina Girva.